The transistors generally, the name transistor, it's a combination of transfer plus resistor. Okay, so that's the single term which is called as a transistor. And here it's a combination, basically it's a combination of two PN diodes. So two PN diodes are going to be combined to form a single three-terminal device. Okay, so the configuration can be either NPN or PNP. So based on the fabrication, how we make the P and the N type semiconductor materials. So transistor is a three-terminal electronic device made of a semiconductor material. So it has the ability to act as a conductor or an insulator. Since it's a semiconductor material, it can act as both conductor or an insulator. The ability to change from these two states enables the device switch or amplify. So basically, we use the transistor as a switch or as an amplifier. Transistors have replaced vacuum tubes and are central to the integrated circuits. So they are playing a vital role in ICs, integrated circuits applications, and it's one of the essential part of many technological advances. So we are using transistors everywhere in almost all the processors, microprocessors, and all computers, processors, and everywhere. Invention was made by John Bardeen, Walter Brittain, and William Shockley in Bell Labs in 1947. So this is the first transistor. How the initial days, how the transistors looks. We have the three terminals: emitter, base, and the collector terminal. So there is a spring kind of attachment here, and this is the kind of arrangement when the transistors were invented. And this is the first junction transistor. We can see the emitter, base, and collector, and how it is being fabricated inside a crystal, single crystal, germanium crystal, where we had emitter, base, and the collector terminals, P and N and P type, P and P term make. Okay. According to Moore's law, here it states that there is a prediction with the number of transistors that has been used every year inside an integrated circuit could be doubled every 24 months. So every year, the number of transistor usage has been increased. So you see here, it is 2,300, 10,000, then 100,000. Like this, it goes on. Number of transistors in an IC, it goes on. And so depending on the number of years, as the years progress, so the processors have been keep on changing. So it started with the 4004, 8008, 8080 processor, and Pentium 2. So like this, depending on the number of increase in the transistor, the processors, the usage of the transistors inside the IC have been the requirements have been increased. Number of transistors, it has doubled every 24 months. So it's a kind of prediction which is done using Moore's law, and the cost of the computers have been reduced. Okay, because of the invention of these transistors. Basically, we have two types of transistors. So one is called that is BJT, bipolar junction transistor, and field effect transistor. So under BJT, we have two categories, PNP and NPN. That is positive, negative, and positive. And here negative, positive, and negative. So here we will study in detail about NPN and PNP types. And under FET, it is categorized as JFET and MOSFET. So we will study about in detail about the FET, its characteristics in module 4. Okay, so module 3, we are going to concentrate fully on BJT. So BJT and FET, the basic difference is, so BJT is a current controlled device, and whereas FET is a voltage controlled device. So we will study about the differences between these two transistors. Finally, once we study both the characteristics, features, and everything. So finally, we will have a comparative analysis between BJT and FET. The BJT analysis. So this is the basic construction. So we have NPN type and PNP transistors. So the transistor is a three-terminal solid-state device which is formed by connecting two diodes back to back, and it has got two PN junctions. So this type of connection offers two types. One is called PNP and NPN types. The three terminals drawn from the transistor, which indicates emitter, base, and collector terminals. Basic structure of a BJT. Okay, So you draw this basic structure. Please draw the structure. So this is for a NPN type. The structure is shown here. So here the term bipolar, it means both the electrons and the holes, they are involved in the current flow. So here we will have both the currents, that is the hole current as well as the electron current for a BJT. And junctions, we have two PN junctions here. So you see here, we have the three terminals, emitter, base, and the collector terminals. So here between emitter and the base, there is a PN junction. So here this is N type and this is P type. So this and N and P will form a PN junction. So this is called emitter base junction. So between the emitter and the base, it's the emitter base junction, which is EBJ. And between the base and the collector, there is again one more PN junction. This is called collector base junction. So this is CBJ. Yes.
Yes, ma'am.
Okay. So now we will study about each and every part of it. What is called emitter, what is base, what is collector region. So this left-hand side of the structure is it's understood as emitter. So this has a moderate size and it is heavily doped. And its main function is to supply a number of majority carriers. That is either electrons or holes. So depending on the doping here, if it is going to be P type, it is going the holes will be the majority. And if it is a N type, it is the electrons will be the majority. So whatever majority carrier it is going to supply. So emitter is going to supply the majority carriers. And as this emitter emits electrons, it's called as a emitter. So if it is a NPN, it is going to emit a electron. So this is indicated as E. So this is going to emit the majority charge carrier. So it is indicated as E. The next is the base junction. It's lightly doped and it is in the middle and it is thin. So it is the function. It is to pass the majority carriers from the emitter to collector. So from E to C, it is just going to act in between both the emitter and the collector. So it is indicated by the letter base B. So next. So collector is comparatively higher in width compared to the emitter and the base. So it's a bit larger in size than the emitter and the base. So it's going to collect the carriers. So either majority carriers, it is going to collect from the emitter. So it's indicated by the letter C. And doping, it's moderately doped. Okay. So this is all about the three different regions. This is the again shown, the detailed structure is shown here for emitter, base, and the collector, and that is for PNP and NPN type, two different configurations. So you see here for PNP, the majority will be here and under the emitter terminal, the majority will be holes. So it is going to emitter will emit holes, and the collector will collect the holes which is emitted by the emitter. And so this base will act as a channel. And for the NPN type, the emitter is going to emit the majority carriers, which is electrons. And collector will collect the electrons emitted by the emitter. Okay, so this is the just to differentiate both the configurations, how it emits the majority carriers. Here again, this is the symbolic representation in terms of a diode. So you see here, basically the transistor is two PN diodes connected back to back. So for NPN, you see here, this is N, that is negative terminal, and this is positive. Both positive are connected together, and this is again negative. So this is negative, positive, negative. Similarly for PNP, this is positive, both negative tied together, and then positive. P, N, and P. So this is how the diodes, two diodes are placed in position. So this is the basic symbol. Okay, so you draw this symbol. So this symbol with the indicated with the arrow, please draw this symbol for the NPN transistor. So for the NPN transistor, you can see the arrow, it is marked outwards. So it is always this arrow will be placed on the emitter junction. And so this will be outwards for the NPN. So this indicates the direction of the flow of the electrons. Okay, so or the current flow. So the current for the NPN, it flows from collector to emitter. You can see the current flows from collector to emitter. The arrow indicates the direction of the current flow.
Ma'am.
Okay. So next will be the symbol for PNP. So you see the PNP, the arrow is indicated inwards. So this inward direction, and the direction of the current flow will be in the opposite direction. That is from emitter to the collector. From emitter to the collector will be the PNP transistor. And from collector to emitter will be the NPN. So you draw the symbol for.
Yes, ma'am.
Okay. Now, so let us see how we are going to give the biasing. Okay, so generally the emitter based junction, whatever it is, either a PNP mode or NPN type configuration, the emitter based junction will be forward biased. So in order to make the transistor work as an amplifier, so we are going to do forward biasing on the, that is emitter based junction, and reverse biasing on the collector based junction. So you see here, this is PNP. PNP, positive terminal is connected to the positive, and this N is connected to the negative terminal of the battery. So this is the battery is generally mentioned as VEE. So positive to positive, negative to negative. This is called forward biasing. And this collector based junction, you see here, positive to negative and negative to positive. So opposite polarities we are connecting. So that's called reverse biasing. And this is for the NPN type configuration, negative to negative, positive to positive. So this is, if you connected similar polarity, it's forward biasing. And then on the collector base, negative to positive, positive to negative. So this is reverse biased. So this is how generally we will bias the transistor. And you can see here, we have placed the transistor along with the symbol. So this is inward symbol pointing at the emitter. So this is PNP type. And this is outward symbol. This is NPN type. And we have forward biased the emitter base and reverse bias the collector base junction. So biasing is controlling the operation of the circuit by providing the power supply. A small forward bias is sufficient at the emitter junction, whereas a high reverse bias has to be applied at the collector junction. The direction of the current indicated in the circuit above, also called as the conventional current, is the movement of the whole current, which is opposite to the electron current. So you see here for the PNP, so the direction is indicated from emitter to the collector. So this direction, it indicates the whole current. And similarly, for the NPN, this is from collector to emitter. So this is the conventional flow of the current from the collector to emitter for the NPN, and from emitter to collector for the PNP. So this is the conventional current flow, which is indicated in this direction. So if you want, you can draw this circuit for second circuit you can draw.